Hi, this is Mike from Software Confidence. Welcome to another episode of Software Success Disciplines. In the previous episode, we created a very simple web application with a build file that enables automated building, testing, and artifact creation. In this session, we'll introduce source code control. Putting this in place will leave us in a great position to push on and do more realistic project work, because we'll have our source code in a managed environment ready for sharing with a larger team. So let's get started by discussing what source code control is all about. Recall our Hello World project. It consisted of a single production file, a JUnit test case, a build file, and a JSP. I'll just show a couple of representative files here. They're stored on the hard disk of our local machine. That means we run the risk of losing them. Also, it's not so easy to share the project with other people or teams who need to make contributions. Source code control addresses these issues. When you introduce source code control to your project, you have a source code control server. Typically, that server will be administered by a dedicated person or team who install the necessary software, ensure there's enough disk space, perform backups, and all the rest of it. In short, hopefully you're in a position to be just able to avail of the service. If not, you should learn how to set up the necessary infrastructure yourself, because source code control is not an option when it comes to successful software development. Assuming the existence of a source code control server, the first thing we do is import our fledgling project into it. The source code control server will keep a copy of each file imported and give it a version number. For the purpose of explanation, we'll pretend that the server stores our project using a simplistic versioning scheme like this, appending the version number to the file name. Now you can delete all mention of your project from your local machine and go about your business. At some point in the future, you may need to come back to your project to fix a bug or add some features or what have you. So you check out a copy of the project from the server onto your local machine. This is called a working copy. If everything goes to plan, you should be able to compile, test, package, and deploy your working copy using the associated Ant script. In fact, it's a good idea to do exactly that to make sure you're starting with a clean slate. Now you can proceed to make whatever changes you need to do on your working copy, get all the tests passing and keeping everything neat and tidy, and when you're done, you check in the edits you made to the server. The server will store these edited files as new versions. You can repeat this process as many times as you like. Going back to our simplistic model of what the server is doing, we can pretend that our files are laid out like this. When it comes to making a release of your software, you can tell the source code control system to remember what version of each file went into making the release. This is usually called tagging. So you say, please tag each of these files as version 1.0. After the release, you can continue improving your software towards version 2.0, and the version numbers in the source code control system will move forward. Our server now looks like this. The current version, highlighted here in green, is stored in the manner we've already seen, each check-in yielding a new version of changed files. But the tagged version 1.0 of the project, highlighted here in red, is a copy of the exact version of every file that went into making the release. In this case, version 4 of our production class and version 3 of our test. An important difference between these two directories on our imaginary server is that the version 1.0 directory is a snapshot and will not accept check-ins, while the current version directory will accept check-ins, allowing us to move forward. By the way, you'll have noticed that I left out some of our project files here to help with focus. A week after the celebrated release of version 1.0, nasty customers report some bugs. Despite our best efforts, some will creep in. Then you can say to the source code control system, please check out the right version of each file that went into version 1.0. When you have 1.0 as your working copy, you can fix the bugs. When you check in, the server cannot just use an available version number for the files you changed, because these are going to make up version 2.0, which could include any number of changes since version 1.0. So the source code control system supports branching, where you can say, make a parallel track of version numbers for all files in the version 1.0 release, and each time I check in a change of the version 1.0 release, move the version numbers along this track. Our server will look like this. It's now got the purple branch of version 1.0 directory containing the history of the edits we're making to version 1.0. As far as the server is concerned, this directory will allow check-ins similar to the current version directory. Once all the bugs in version 1.0 are fixed, we can release version 1.1 and tag all the constituent files accordingly, which means our server will be in this state, with another tagged version of our software, version 1.1 this time, containing version 4.2 of the production class and version 3.2 of our test. In summary, we have a directory of version numbers moving forward towards release 2.0 of our software in the form of current version, and a parallel directory of version numbers moving forward towards release 1.2 with the rather clumsily named branch of version 1.0. If we inch our way forwards and do some very simple renaming and restructuring, we'll get a lot closer to what really goes on inside a source code control server. Let's rename current directory as trunk, and the clumsy branch directory as a directory called branches, containing a subdirectory called version 1.0. Finally, let's move our two tagged versions into a tags directory. This gives us new vocabulary to work with. Trunk is the current version of our software as it's in development, and it can accept check-ins. A branch moves towards an improved version of an already released version, and it too can accept check-ins. A tag is a snapshot of all the files that went into a particular release and does not accept check-ins. Meanwhile, following our release of version 1.1, it's very likely that the fixes we made to version 1.0 also need to be applied to version 2.0. So the source code control system provides tools to help us merge changes from branches to trunk, so we do not have to manually redo all the work. We can say to the server, decide for yourself what changes we made between these two versions of a file, called a diff, and apply it to the latest version of the same file. Another essential feature of source code control systems in software development projects is support for teams working on the same code. Several team members or pairs can have their own working copies checked out at the same time, all making their own changes. When the first pair checks in, it's business as usual. The server stores a new version and increments the version number. But when the second pair check in, things have moved on the server, and they need to merge their changes with whatever the first pair added. Usually the server takes care of this automatically if the changes are non-conflicting, but sometimes manual intervention is required. It's the same mechanism as merging changes from branch to trunk that we discussed earlier. The discussion so far has used vocabulary that is very biased towards a source code control system called Subversion, because that's what we're going to use in the screencast. There are many excellent options out there in this space, all with their own particular vocabulary, but they will or should offer features similar to what I just outlined. It should not matter which one you pick, as long as you're comfortably able to do the equivalent of checking out, checking in, branching, tagging, and merging. One final consideration when it comes to choosing your source code control system. Make sure all the operations are suited to automation, either through the use of a command line or and tasks or what have you, because we're going to make use of that in the near future. Right, let's get down to some real work with Subversion. Let's see what's involved in importing our project.